Ooh, that was loud. All right, number 4 from yesterday's worksheet. If f prime of x equals cosine of x cubed, f of 0 equals 2, find f of 1. Okay, let's see. If I have f prime and I want to find f, then I need to back up one, right? Capital F goes to little f, goes to f prime, goes to f double prime. It's a little our progression of derivatives and antiderivatives. So if I'm at f and I want to get to, I'm at f prime and I want to get to f, I should integrate or antiderivative f prime, and that would get me to f. But I need to know what x values I should use. So what x value should I use? 1 and 0. The only x values I've got in the problem. So 0 to 1. So 0 to 1 of cosine of x cubed dx equals, f of 1 is what we're looking for. F of 0 is 2. So 2 plus whatever that is. But again, this is a calculator problem. I don't think we'll ever be able to antiderivative that by hand. So Math 9 is our magic calculator button. Antiderivative of cosine of x cubed from 0 to 1. Oh, make sure I'm in radians. And then plus 2. So f of 1 is 2.932. Do I still need to do number 5, or is that close enough?
I got it
How about one of the word problems, or 9, 10, and 11 are pretty, I don't want to say simple. None of this is simple. Similar to the ones we did in the homework, or in the notes, I should say. Number 12. And there's room to work, number 12. Let f be the function whose graph goes through the point 3, 6. Okay, well that's a fancy way of saying f of 3 equals 6, if it helps to write it that way. Or I guess it's an unfancy way of saying f of 3 equals 6. Whose derivative is given by this, find f of 3.1. Well, we know f prime, we're looking for f, so we need to antiderivative f prime to get to f. Yeah, I'm thinking this in my head. It's no crime to write it out if you need to see it visually of taking derivatives, taking antiderivatives. So if I know f prime and I want to get to f, that is on the antiderivative way to go. Our x values are 3 and 3.1. So smaller one to bigger one, and then top one minus bottom one. So this will be another calculator problem, unless somebody knows how to take the antiderivative of that thing. No one does. And f of 3 is 6. So the problem was stated a little different than number 4, but it turned into a very similar problem. Math 9, 3 to 3.1 of, put the fraction bar in there, e to the x over x squared dx. Not that you need this, but you might remember that means the area under that curve between 3 and 3.1. So don't lose sight of that, because sometimes that's the way we need to think of it. But thinking of it that way doesn't really help, because who knows what that graph looks like. But it's still the area under that curve. Be careful, that's not my answer, right? That's what this integral is. So I need to add 6 to that. So 6.238. In a minute, we'll start writing them a little bit more often like that. It's just rearranged. If you start at f of 3 and you add from 3 to 3.1, you land at 3.1. But it's the same thing as how we wrote it initially.